Chapter 11 Objectives. Identify structural formulas as alkenes, cycloalkenes, and alkynes, and write their IUPAC or common names. Draw the condensed structural formulas and give the names for the cis-trans isomers of alkenes. Draw the condensed structural formulas and give the names for the organic products of addition reactions of alkenes and alkynes. Draw condensed structural formulas of monomers that form a polymer or a 3-monomer section of a polymer. Describe the bonding in benzene. Name aromatic compounds and draw their condensed structural formulas. Chapter 11 is all about unsaturated hydrocarbons. 11.1 is on alkenes and alkynes. And you wonder, why are we seeing welding, a picture of welding here? Well, that's because the fuel that's used in the torch, acetylene, is an example of an alkyne. Now, in the past, chapter 10, we were talking about saturated hydrocarbons. That's where you had the maximum number of hydrogen atoms attached to each carbon atom. They were all single bonds. Single carbon-to-carbon single bonds. So yes, carbon always had 4 bonds, but it was all a single bond, whether it was between a carbon to a carbon or other hydrogens. And so even with a cycloalkane, we have all single bonds. These are considered saturated hydrocarbons. No place to put any more hydrogens there. Whereas in this chapter, we're talking about unsaturated hydrocarbons. Now, in unsaturated hydrocarbons, that kind of refers to the fact that because there are fewer hydrogen atoms attached to the carbon chain than the alkanes, there are ways to add hydrogens to make it saturated. So right now it's unsaturated because we can actually add hydrogens to these double bonds, and that's going to be a process in another section. But right now, think of unsaturated hydrocarbons as items of those that have something other than just single bonds. So an alkene has a double bond, at least one double bond, and the ene ending refers to a double bond. So here is a 2-carbon item. So its prefix is F, and because it's a double bond, we're going to name the ending ethene, not ethane. Ethane would just mean single bonds. Now, an alkyne has triple bonds. The YNE, the ine ending, refers to the triple bond. So here is an example of our smallest triple bond compound, which is going to be 2 carbons. Well, so the prefix for 2 is F, and we need to make sure that we know the ending represents a triple bond, so ine, so ethyne. Notice this triple bond. So these black balls represent carbon. Notice carbon still always has 4 bonds. It has this triple bond and a single bond to the hydrogen. So with our alkene, for our carbon, we have 2 carbons and 4 hydrogens. So the formula for an alkene would be CnH2n. Whereas for the formula for an alkyne is going to be CnHn. However many carbons there are, there's that many hydrogens on, for example, of ethyne. I will just give that example. Now, according to the valence shell electron pair repulsion theory, that means that the pairs of electrons want to get as far away as possible from each other. Well, if we have 3 areas, so we have around this carbon, we have this area of electrons and this area and this area. So because there's 3 areas, the farthest they can get apart is 120 degrees. Now, with that 120 degrees, it's also all in one plane, i.e., it is all like 2-dimensional there per se. I mean, it's not 2-dimensional, but it's all, I call it the squish spider view, is the view. It's all in the same plane, which comes very important to an item about cis or trans, which we will talk in a later section. Now, our triple bond, our alkyne, is going to be the hydrogen is going to be at 180 degrees away from the triple bond, so that it is as far away as possible, like a straight line, 180 degrees. All right, let's talk about ethene. Well, ethene is such a common building block of polymers when we're talking about polymer chemistry, And it was used a whole lot before they had developed our IUPAC system of naming, which our IUPAC system as naming came along because they started getting so many compounds, they had to start finding a method to the madness. But because ethene was around and named before then, it really is more talked about with its old common name of ethylene. So please don't infer anything with this Y. Ethylene is the old common name for ethene. But the old common name is actually the one that's used most prevalently now because it is such a basic building block of polymer chemistry. And now it is the simplest alkene with the formula C2H4. We've already talked about that it's flat, it all lays in the same plane. But what's also interesting is that it is a plant hormone used to accelerate the ripening of fruits. So besides its use in polymers and plastics and about everything plastic that you have, it's also, when they pick fruit and store it, before it's ripened, they can store it for a long time. And then when it's time to pull it out, to bring it, out to put out for sale, they can spray on this ethylene, which is a hormone used to accelerate the ripening of the fruit. Now here's some other examples of compounds with double bonds that are in items we might know. Okay, so like lemons, this thing called limonene, this compound called limonene is a basic item of limonene. Okay, this compound, geraniol compound in roses, and probably you might guess where this name came from. So let's go back to our welding picture at the beginning. The simplest alkyne would be ethyne. However, ethyne is not the name that if you're going to go and talk to somebody who's a welder, if you say, "Oh yeah, I know all about ethyne," he'll look at you kind of going, "What the heck are you talking about?" Its common name is acetylene. Again, there's no, don't try to figure out where the heck that came from because, the method to the madness is kind of long and don't have to worry about that. But use the word acetylene for our ethyne. 2 carbon, triple bond. Why would we use acetylene? It's because if we don't use the term acetylene, then nobody that's not a chemist will know what we're talking about. All right. Now then, let's name some alkenes and alkynes. When the carbon chain of an alkene or an alkyne has 4 or more carbon atoms, number the chain to give the lowest number to the first carbon in the double or triple bond. So, if we don't have any substituents on there or anything, well, actually if we do, but it's still the same thing, we are going to number it so that the double bond, the numbering goes through the double bond. Now, we are not going to start right and go left because that's not going to put the double bond to have the lowest number. We're going to start from the left and go right. So the double bond, we're going to have 1 butene. Why? Because we have 4 carbons, that's bute. We have ene because that's a double bond. We have to tell everyone where that double bond is located. It's on carbon 1. Now then, let's have the double bond here, and you'll notice we're going to number it 2 butene. Now let's see, here let's look at this, 1, 2, 3, 4, 5. If we were to number 5, well, we know that's pent, and then a double bond, ene. Now then, let's see, do we number it from the left and go right, or the right and go left? Well, if we number it from the right to go left, we are going to have the double bond start at number 2, which is lower than if we went the other way, which would have it at 3. So it is 2-pentene. So guide to naming alkenes and alkynes. Name the longest carbon chain that contains the double or triple bond. Number the carbon chain starting from the end near the double or triple bond. Give the location and name of each substituent in alphabetical order as a prefix to the alkene or alkyne name. So here we have 2 examples. Let's look at example A. So we first name the longest carbon chain that has the double bond. Okay, so 1, 2, 3, 4. So we know the ending is going to be butene because there's a double bond. And on this problem here, let's see, longest continuous chain with a double bond, 1, 2, 3, 4, 5. So it's going to be pentene. Okay, let's continue. Now then, we got to number whereabouts is that double bond located? So on the first one, the double bond we're going to number from the right and go left, and it's going to be starting at the 1, carbon 1. So this 1 tells us that that's where the double bond is located. So 1-butene. Okay, on the pentene one, the double bond is over here, so we're going to put our numbering. We're going to start from the left and go right. 1-pentene. All right, so now then, let's go back to problem A and figure out this methyl group, how we're going to identify it. Well, we've already just established that we are numbering from the right and going left because we are numbering through the double bond. So that means carbon 1, carbon 2, carbon 3. That means this methyl group is on number 3. So 3-methyl-1-butene. Over here, we have the double bond starting from the left and going right. So that's where our numbering is going to be. So this methyl group here is on the carbon 2. This methyl group here is on carbon 3. So 2,3-dimethyl-1-pentene. Okay, with an alkyne, we're going to name it exactly the same way except change the ending of the name from E-N-E to Y-N-E. So 1, 2, 3, 4, 5. Pentyne. Okay, and we notice that the triple bond is starting at carbon 1. So 1-pentyne. Now then, we have these two methyl groups on carbons 1, 2, 3, and 4. So 3,4-dimethyl-1-pentyne. All right? See if you can write the IUPAC name for each of the following. Press pause and do this. All right? Write for our last one the IUPAC name for each of the following. Press pause and see if you can do this. All right, if you have any questions, send me an email and we can talk on the phone to help you with any of these. Because I know that on one hand it might appear hard, but no, with a little bit of practice, you will be able to get this.